Lesson 2.7, solving absolute value inequalities. So an absolute value inequality is another way of representing a compound inequality. Okay? We have two types of compound inequalities, and or, and we have two types of absolute value inequalities. Okay? We have ones that have your absolute value isolated on the left, okay? And we have either a less than or a greater than, okay? And it could be less than and or equals to, or greater than or equals to. That doesn't really change the way you work the problems. All right. An and inequality will always have the isolated absolute value on the left and a less than sign. Okay? An or absolute value inequality will always have the absolute value on the left isolated with a greater than sign. All right? One thing to remember is when we have an absolute value, okay, just an expression with an absolute value, all right, this number, this value, could be either a positive x or a negative x. And when we break into our two cases, that's kind of what we're going to say, right? This could either be x or negative x. All right? It's important to remember that because when we're using absolute values in equality or in equations, we often skip a step that we don't really need to think about when we're doing them, but becomes very important when we're dealing with absolute value inequalities. All right, so if I break this into my two cases, I'm going to have my positive case, x is positive, and it is less than 3. Right? My other case, this is very important, my other case is not x is less than negative 3. Okay? It is not x less than negative 3. All right? What it is negative x is less than 3. All right? And with an equality, this is the same. Right? If this is an equal sign, negative x equals 3 and x equals negative 3 is the same because we only need to come and multiply both sides by negative 1. Oops. Multiply by negative 1. And that will change it, right? That'll change it into the other form. With an inequality, what happens when we multiply by a negative? Well, it changes things, right? Those still cancel. We're left with x, but we're multiplying by a negative, so we got to flip our sign. 3 times negative 1 is negative 3. All right, so you can jump straight to this step, but you have to remember, to flip that sign. Okay, that's one of the most common mistakes that people make, both in normal inequalities, right, solving multi-step inequalities, and in absolute value inequalities. Okay, you're going to change the sign for your negative case. Okay, and then this one, same thing. We're going to have our positive case, where x was positive, and then we're going to have our negative case, where we had a negative x and a positive 3, multiply by negative 1, multiply by negative 1, cancel, x, flip the sign, negative 3. Okay, so we've got our two cases, and if you can't remember which one is and which one is or, that's okay, because when you graph them, you should be able to tell. So we have x is less than 3, so we draw our open circle, and I'm going to put it down here, my arrow, because it's going to go from here with my open circle, and it's going to go less than, so it's going to go to the left, and that's my solution set for x is less than 3, right? I'm going to look at my next one. X is greater than negative 3, so I draw my circle, and then it's greater than, so it's going to go to the right. Okay? Anytime you have two equalities or two inequalities overlap, that makes it your AND compound inequality, right? Because we're going to be looking at solutions that satisfy both of these inequalities. Okay? And that'll be anywhere they overlap. All right? If we look at our other case, our OR case, we have same thing, 3 and negative 3 are our endpoints. X is greater than negative 3, so it would look like that, and x is greater than 3, and x is less than negative 3. So these point away from each other, so I can go ahead and draw my solutions in, and we can see that they never overlap, and this is an OR case, right? It's an OR compound inequality. Okay, so when we're solving absolute value inequalities with the less than sign, we've already seen that these should all be AND inequalities. All right, all we have to do is put together our previous rules. Okay, so all of our absolute value inequality rules and all of our absolute value equation rules. Okay, so I've got x minus 2, the absolute value, plus 3 is less than 5. The first thing I have to do is isolate, subtract 3 from both sides. X minus 2 is less than 2. Break into my two cases. My positive case, x minus 2 is less than 2. And then I'm going to break into my negative case. And as long as you're remembering to flip the sign, you can skip the assigning this as a negative. Okay, we can skip straight to the next step. So we would have x minus 2 is greater than negative 2. All right, got my two cases. These aren't isolated variables though, so now I've got to isolate my variable. I'm going to add 2 to both sides, add 2 to both sides. These cancel. 2 plus 2 is x is less than 4. 2 minus 2, or negative 2 plus 2, is going to be x is greater than 0. Okay, and then I'm going to graph it. The graph's way down here. Bring that up. Okay, and I'm going to graph it. X is less than 4. Draw my open circle. Draw it up here. Less than 4. It's going to go that way. And then x is, my endpoint is 0. And x is greater than 0. So I'm going to start at 0 and go to the right. I can see my two lines are overlapping. And that is going to be my solution.